Hi ladies, this is lesson 8.1 and this video is about areas of triangles and special quadrilaterals, and we'll look specifically at parallelograms, trapezoids, and kites. The area of a rectangle should be a review for you, but we'll go over that just in our warm-up exercise. So I want you to take a look at this warm-up, and the first question is, what is the area of a rectangle? And secondly, what is the perimeter of a rectangle? So take a couple seconds to look at this figure, pause the video while you work, and answer those two questions. And then think about what it means, what the area means, and how does that compare to perimeter. The area of a rectangle, you can use this formula that's outlined on your note sheet. Area equals base times height. Or you might often see this written as, for rectangle, area equals length times width. And really for rectangle, length and width, or base and height, those really are interchangeable, but we're going to get into more specifically what base and height is looking at other polygons. So in this figure, what is the area of a rectangle? The area is the base times height, so that's 8 times 6, 8 feet, times 6 feet, which is 48 feet squared. Or you might see it as square feet. It's not 48 squared, it's 48 square feet. The feet, the unit, is what is being squared. And the second question, what is the perimeter of a rectangle? Well, if you think of perimeter, that's what it takes, how much fencing you need. So that's the distance around the polygon. So in this case, this is a rectangle, which means opposite sides are congruent. So we're just really adding up all the sides, or we can say 8 times 2 plus 6 times 2. Which is 16 plus 12, which is 28. And here, our units are just feet, because we have feet plus feet, not feet times feet like we did in area of a rectangle. So now that we know that the area of a rectangle is base times height, we can define some of our vocab terms. And the first one is area, and we're going to define area as the measure of the interior space as the figure. And secondly, we're going to measure it in square units. Then our second term is base. And with a rectangle, it doesn't really matter which side we call the base. We can, if you look at this figure to the right, this could be our base, or this could be our base. Generally, we think of base as the bottom of a polygon, but it really doesn't matter in a rectangle what we define as base. But for height, it does matter. Our height we're going to define as the length of the side that's perpendicular to the base. So again, it doesn't, in a rectangle, it doesn't matter which side is the base. It can be any side, but the height is the side that's perpendicular to it. Let's look at this figure, and this is the rectangle that we looked at in the warm-up exercise. And how does the area of a triangle relate to the area of a rectangle? Well, if you look at this figure, we can look at this as the area of a triangle, just this yellow region. That's our triangle area. And if you think about it, 2 of those triangles fit inside of our rectangle. So developing a formula for the area of a triangle, we're going to say that's half of the area of a rectangle. So that's 1/2 base times height. Now let's look at another quadrilateral, and this is a special quadrilateral again. How does the area of a parallelogram relate to the area of a rectangle? Well, we have the same measurements. We have 8 feet as a base, and 6 feet as a height. So if you think of this parallelogram, if you cut off part of this parallelogram, if you cut off this little triangle here and you moved it over here, we would have a rectangle. This would be a rectangle. So the area of a parallelogram is the same as the area of a rectangle, which is base times height. Now it's important that you know that the side length does not equal the height. So we need this perpendicular measurement. This 6 feet has to be perpendicular to the base. If we had 6 feet here as a side measurement, if this was 6 feet and we didn't have this measurement, then we would have to do some computations in order to get the measurement for the height. But for your formula, you're using the height as what you're multiplying the base by in order to get the area, not the side length. So that's very important as you go through and work through some of your homework problems. All right, now next let's look at a trapezoid. And this one's a little bit harder to imagine because the formula is a little bit more complicated than a rectangle or a parallelogram or a triangle. But if you look at this trapezoid, you see all of those shapes within the trapezoid. So we know that there's going to be some relationship between trapezoid, parallelogram, rectangle, triangle. So we know that the triangle has an area of half base times height, a rectangle has the area of base times height, and a parallelogram has an area of base times height. Well, looking at this trapezoid, you can see that base 1 and base 2, those are different lengths. So base 1 is clearly longer in this diagram than base 2, and this is not a special trapezoid, it's just a normal trapezoid where it has one set of parallel sides, so the two bases are parallel. We have a height measurement, or we have a variable that we're using for height, and then we have a side measurement, s, that we're using as a variable for the side. So let's think about how we can rearrange this trapezoid and develop a formula. So we're going to use the shape parallelogram since we already know the area of a parallelogram. And if you look at this diagram that's on your note sheet, just with a little reflection, we can see that this shape is a parallelogram. Okay, the orange is the reflected image of the black trapezoid. And if we overlap them a little bit, we can see that it's a parallelogram. So let's try to rearrange our trapezoid so that it looks like a parallelogram. So, and you can do this on in your notebook. If you draw a trapezoid and then duplicate that trapezoid, so trace it or draw two trapezoids that are exactly the same. And then if you cut them out, try to rearrange that so that it looks like a parallelogram. So what I'm going to do here is I'm going to take this orange, that's my duplicate image, and I'm just going to rotate it so that it looks like a larger parallelogram. So I just flipped this so that this side right here, S, this is the same. So I'm making it right now so that there's no overlap between my two trapezoids. They're not, like in your diagram here, they're overlapped, but just so you can see a little more clearly, if I take those two trapezoids and this red segment, that's side S for both of them, the shape I have now is a parallelogram. I have two trapezoids that form a parallelogram. So let's think about what this looks like if I were to develop the formula for the parallelogram. So in this figure, the area of my parallelogram would be base 1 plus base 2 times height. I have to make sure that I group these two bases together because of order of operations. So base 1 plus base 2 times height. Since this is parallelogram, this segment and this segment, opposite segments, are congruent, and same with these two. Opposite segments are congruent, which I already know from, because it's a reflected image, or it's a rotated image of the orange trapezoid is a rotated image of the black trapezoid. So I know that those two are exactly the same. I know that side S here is exactly the same. It's not overlapped at all because it's the reflected image, or it's the rotated image of that original trapezoid. So my parallelogram is base 1 plus base 2 times the height. That parallelogram is two trapezoids. So my trapezoid area is what? If base 1 plus base 2 times the height is the area of my parallelogram, which is two trapezoids, then my area of a trapezoid is 1/2 times base 1 plus base 2 times my height. And that's going to work with any trapezoid. This is not a special trapezoid. It's not an isosceles trapezoid. It's just one not specific trapezoid, just a very generic trapezoid. So my area of a trapezoid is the average of my two bases, so my base 1 plus base 2 divided by 2, times the height. Now let's look at the area of a kite. If you look at the kite, you see 4 triangles, and within those 4 triangles, you know that they're both isosceles, or they're two pairs of congruent triangles. So if you look at the 2 big triangles, you know a kite is made up of 2 isosceles triangles. Here's one isosceles triangle, and here's another isosceles triangle. All right, furthermore, you know that this triangle and this triangle, those are congruent. And secondly, that this triangle and this triangle are congruent. So you have 2 sets of congruent. So those dotted lines that you see, those are the diagonals. So let's look at our 2 diagonals. We'll call this diagonal 1, and we'll call this diagonal 2. So let's think about how we can rearrange this kite in order to make something that we already know. Now, we don't really know the length of just this part of the second diagonal, or we don't really know the length of, well, we know that the length of this first diagonal, the second diagonal bisects the first diagonal. So we do know that, but we don't really know exactly how far, this segment is in relation to the second diagonal overall. So let's think about rearranging this. So if we move this triangle it'll fit right here, okay, because it's congruent to the first triangle, the other yellow triangle. And if we do the same thing over here, let's move this triangle up here. All right, now we have a rectangle. So our rectangle is going to be the rectangle of the area of the whole rectangle. So if we were looking at this whole rectangle here, if we were looking at this whole rectangle, it would be the first diagonal times the second diagonal. But we're not looking at the whole rectangle, we're looking at half of that rectangle. So we're only looking from here to here. And we know that since the second diagonal bisects the first diagonal, that this is exactly half of the first diagonal. So half of that first diagonal times our second diagonal is the area of our kite. So you can always try to rearrange these polygons that you don't have exact area formulas for into polygons that you do have area formulas for. Like in this case, we thought about some properties we knew about a kite. For example, that the second diagonal bisects the first diagonal, and we use that to rearrange our triangles into a rectangle, which we have an area formula for. So in this next extra example, we know the area and we're looking for x. So in this diagram, this is a trapezoid. So we know that x, and we know that x is the height because it's the perpendicular segment to the base. So our formula for a trapezoid is area equals 1/2 base 1 plus base 2 times height. We know that the area is 63 inches squared, so we know that that is 1/2 of 10 plus 4 times our height. So 63 is 1/2 of 7 times h. Oops, 1/2 of 14, sorry. So 63 is 7h, and if you divide both sides by 7, and actually I'm going to replace these h's with x because that's really what, in this problem, our height is x. So if we divide 63 by 7, we get 9. That equals x. And anytime you're finding sides or area or anything and you're given any units as measurement, you want to include those units in your final answer. So x is 9 inches. In this next figure, this is an irregular shaped figure, but we're going to take what we know about perimeter and area of figures that make up this more complicated figure. And if you look at this, you see a couple parallelograms. So I see a parallelogram here, and I see a parallelogram here. I know that those are parallelograms because they have the parallel line markings. And then I also see that this is marked as 8 centimeters, and this is marked as 28 centimeters. So first I'm going to find my area. So I know that the area of a parallelogram is base times height. So I'm going to take the base times my height of that larger parallelogram, and I'm going to add that to the base times the height of my smaller parallelogram. So 40 times 28, that's my smaller parallelogram. That's my larger parallelogram, and that's 1120. And my smaller parallelogram, 40 times 8, is 320 centimeters squared. So 320 plus 1120 is 1440. And to find my perimeter, I'm going to add up all of my sides. So 40, I know that this is 10, this is 40. I can figure that this is 9 because it's 30 minus 11 minus 10. So this whole thing would be 30, and I'm going to subtract 11 and 10. And I'm going to add 40, add 11, add 40, add 30. So my total perimeter is 220 centimeters. So please jot down any questions you have and bring them to class next time I see you. Thank you. Thank you.